All right, good morning, or actually good afternoon, everybody. Let's go ahead and get started. So your notes should be out. We are going to be looking at 3.5 sinusoidal functions today. Yesterday we built our sine and cosine functions, so I just want to go back and review our findings for that. So there is our sine function. Yesterday we did not do the entire table, but this would be the entire table for our full unit circle, and that gives us the full graph of sine, well, at least one period's worth of sine. Now remember, sine, cosine, they are periodic relationships, periodic functions, so they just keep on repeating themselves. And the part that repeats is the period of the function. We're going to be finding the period of functions today. So that's our sine. And then cosine, hopefully you took some time to finish out cosine. But that would be the full graph of cosine there. If you did not get the chance to finish that one out, please take some time to do so. But again, that would be using the horizontal distances at each of the points. And we have our full table going through there, all the way from 0 to 2 pi. 0 at 1 and 2 pi again at 1. So today we're going to be looking at different characteristics of the sine and cosine functions. So again, these are our sine and cosine functions, the parent functions of sine and cosine. Tomorrow we will be looking at different transformations applied to sine and cosine, horizontal and vertical shifts, horizontal and vertical dilations, all the same transformations that we've been looking at all year, we're going to apply to our sine and cosine functions. Now, why is this titled sinusoidal functions? Well, a sinusoidal function is a function that involves additive and multiplicative transformations of sine, the function sine of theta. So it actually ends up that cosine is a sinusoidal function. It's the graph of sine just shifted horizontally, and that's what we're going to be looking at here, is that both sine and cosine are sinusoidal functions, where cosine can be written as sine with a horizontal shift. And we can see that right here. We're saying cosine is equal to sine of theta plus pi over 2. And so we see this plus pi over 2. What kind of shift is this? If we are inside the function, what kind of shift is that? A horizontal or a vertical shift? That's a horizontal. Which way did we go? Left or right? If it's plus, that'd be left, right? Remember, we do the opposite of what we see. So this is actually a shift left by pi over 2. And we can go ahead and see that in our graph. So we have our blue sine function. So yours on your paper isn't blue, but you can highlight it if you want. But on mine, the sine function is blue, the cosine function is in black. And we can see if we take any point on my sine function, let's do that maximum value there, and I shift it left a distance of pi over 2, which we can see that that's a pi over 2 because of our x-axis there. That's a distance of pi over 2. And so that one shifted left a distance of pi over 2, and it dropped on top of cosine. And every point from sine shifts over to cosine. So here's a point on sine, and we shift left that pi over 2, and there it's matching point right there. We can take the minimum value over here, which would be at 3 pi over 2, and that would shift over that distance of pi over 2 over there. So we see that horizontal shift left pi over 2, and that lands our sine function on top of cosine. So cosine is just a horizontal shift of sine. That's all cosine is. We could even do a different shift if we wanted to. What if we went ahead and looked at this maximum value there and say we want to shift it over to this point here? Could we do that? And would it land on top of cosine again? Yeah, it would. How long is that shift? Well, let's think. Every 2 spaces was pi over 2. So this would be 1 pi over 2. Another 2 spaces, that would be how many pi over 2s? I forgot to do negative. That'd be negative 2 pi over 2. Well, what's 2 over 2? So that would be negative pi. And then 2 more spaces would be negative 3 pi over 2. So this was a shift right by a space of 3 pi over 2. So I could also write this would be or cosine is equal to sine with this time a right shift. So I know it's by 3 pi over 2. Would that be plus 3 pi over 2 or minus 3 pi over 2? Why minus? Because we're shifting right? So minus 3 pi over 2. So both of those would be a valid transformation. I could even do something different. If I went all the way, continued my wave around back over to the next maximum, I could take that maximum and shift it all the way to the y-axis. And that would be another shift. So cosine, again, is just a horizontal shift of sine. And so therefore, since they're pretty much the same exact function, just shifted apart, we then give them that umbrella title of sinusoidal functions. It's a very interesting word, sinusoidal, but that's what they would be. And they get the word sinusoidal. I don't know exactly all the root and everything, but I do know that it does have that root of sine in it, right? So sinusoidal functions are any function of sine or cosine. So whenever you see a sine or cosine function, and it could have, reflections and shifts and dilations and all that stuff applied, but if it is a sine or cosine function, shifted and dilated around, it is a sinusoidal function. And that's important to know because all sinusoidal functions have the same characteristics. And that's what we're going to be looking at now, the characteristics of sinusoidal functions. So every sinusoidal function has the following characteristics: period, frequency, amplitude, midline, and being even or odd. But especially the ones I want us to focus on today is the period, frequency, and midline. We will need to be able to recognize and describe these different characteristics of a sinusoidal function. So, first off, the period. We're familiar with that. We've talked about the period of periodic functions before. So the period is the change in theta values required for the function to complete one full cycle. So that period is the length of the graph that gets repeated over and over and over again. And so we see that highlighted on our graph there, the period of the function, which is that chunk of the graph, right? That chunk of the graph that repeats. And if we go back up to like this one up here, we can kind of see that happening, right? I have this chunk of my graph that gets repeated over and over and over and over again. So that's the period. The new ones today are the frequency, amplitude, and midline. Frequency is easy. as long as you know what your period is. The frequency is just the reciprocal of the period. Okay. Now, to get into, if you're to look at context and stuff like that, the frequency is the number of cycles the graph completes per 1 radian. So the smaller the period, the higher the frequency, actually. But we'll talk about that more later. Really, what you need to know now is the frequency is the reciprocal of the period. The amplitude, which I have labeled on my graph there, is the half the distance between its maximum and minimum values. I also like to think of it as the height of the bumps. So often I like to find my midline first, and the midline is just the middle of the graph. Every sinusoidal function is going to have a middle of the graph where the maximum and minimum points are the same distance apart from the midline. And so that amplitude is the same distance from the midline to the maximum and the midline to the minimum. That amplitude ends up being the same exact distance. But you can also think about amplitude as if you take the height from your maximum to the minimum, take that full distance, and then cut it in half, then you get your amplitude. That'd be another way to think about it. Okay? All right, so again, midline is the middle of the graph. It's the horizontal line halfway between the minimum and the maximum values. And this is also an important thing. It is determined by finding the average of the maximum and minimum. How do we find average again? Does anybody remember? Let's just think. If I gave you two numbers, I don't know, 5 and 3, what's the average of 5 and 3? Huh? How do we know? Good. So we add, and then we divide it by the amount of numbers I have, which in this case is 2. What if I had 5, 3, and 11? What do I do? Add up and divide by 3. Good. So 5 plus 3 plus 11 divided by 3. So average, we just add up. So if we're doing the average of the maximum and minimum values, add the max and min and divide by 2. If you want to write that down here, we can. There's a little bit of room here. So we're going to go ahead and say that that would be the max plus min divided by 2. Okay, so that'd be the average of the maximum and minimum values. And that would equal the midline. All right, another interesting characteristic is that the concavity of the sinusoidal function will change as it crosses the midline. So if we look at this chunk right here, is this concave up or concave down, the part I just highlighted? Concave down, and then it changed after the midline. What is it now? Concave up, right? So every time we cross the midline, we change concavity. Those are going to be our points of inflection when we change concavity. So over here, I'm going down my graph, it's concave up, but then I cross the midline, and now I'm concave up. Went from concave down to concave up. Okay? So that would be concavity, midline and concavity. We also have changes in increase into decreasing, and that changes between our max and min values. But even in odd, the graph of sine has a rotational symmetry about the origin, therefore is an odd function. And the graph of cosine has a reflective symmetry over the y-axis, therefore is an even function. If you want to look more on even and odd functions, we did a little bit of that back a few units ago. So back at that, I don't remember exactly which section of notes, but looked at that a little bit more. But that's not going to be our focus for today. We're going to be identifying period, frequency, amplitude, and midline for some graphs. So let's go ahead and turn the page and look at problem number 1 here. We're going to start with sine. All right, so sine of x. So we want to start with the period. So this is the part that repeats itself. So often, especially with just sine and cosine, we can, it often is easy to start at 0. And then where does the graph start repeating itself? If we travel along our graph, where does it start repeating itself? At what value of theta? At 2 pi, right? So we're going from 0 to 2 pi. That is the length of our period. Length of 2 pi. We could also do that in a different way. I could have gone from pi over 2. Let's see. We could have gone pi over 2 to 5 pi over 2. That would have worked as well. All we would have to do from there is take my 5 pi over 2, the second one, the ending one, and subtract the beginning one. What is 5 pi over 2 minus 1 pi over 2? 4 pi over 2, and 4 pi over 2 reduces to 2 pi, which is the same thing. Okay? So, a period is a distance of 2 pi. What did I say the frequency is? What is the frequency? The reciprocal of the period. How do I find the reciprocal of 2 pi? Well, literally, we just do this. 1 over 2 pi. There we go. All right, amplitude. What is the amplitude? Actually, often I like to do midline first, so I'm actually going to find the midline first. What is the line that goes through the middle of our graph? It's going to be a y value. So this is a midline. It is a line, and we're going to write it as y equals. What is that equation? What is that line? Y equals what? 0 in this case, right? So y equals 0 is our midline. And now amplitude is that distance from the midline to our bumps. What is the height of those bumps? A distance of 1, right? So my amplitude is 1. Okay? And there we have those different characteristics of the sine graph. All right, go ahead and do that for cosine, please. Identify your period, frequency, amplitude, and midline for cosine. All right, Nathan, what did you get for the period of cosine? For the period? Okay, so you have 3 pi over 2 here. What would have been your starting point, though? Because if we start at 0, that would have been up here, and that doesn't match. So we can do 3 pi over 2, but then we'd have to start here at negative pi over 2. Okay? So then what is that distance? Which we can definitely do, but then I'd have to do that subtraction. So 3 pi over 2 minus negative pi over 2, which would become adding. What is 3 pi over 2 plus pi over 2? 4 pi over 2, which reduces to 2 pi. So that's a distance of 2 pi. So remember, we're looking for that chunk of the graph that is going to repeat itself. And when we find our period, we should always, if we start at the midline, then our period is going to end at the midline. If we're starting up at a maximum here, then we would end at the maximum. Okay? But that distance is 2 pi. Brandon, what would be my frequency? 1 over 2 pi. Good. Dean, what's my amplitude? 1. So that's the height from my bump to the, in this case, the x-axis, but the midline. And Ava, what is my midline? Y equals 0. Thank you for giving that to me as an equation of a line. Y equals 0. All right. Okay. Is everybody good with sine and cosine? What did we notice about their characteristics? They're exactly the same, right? They share the same exact characteristics. Sine and cosine have the same period of 2 pi. Their frequency is the same. Their amplitude is the same. Their midline is the same. Again, they're just shifted off from each other, right? Sine starts its main period at 0 and goes around back to 0, whereas cosine starts its main period at 1 and goes around and ends at 1. All right? So, I want you guys to go ahead and look at problem number 2. We have 2 graphs here, A and B. I want you to go ahead and identify period, frequency, amplitude, and midline for each of those. Okay, let's go ahead and look at this one. Start with A. Let's see. Zach, what is my period for A? And what x values did you go from to determine that? Pi over 2 to 5 pi over 2, this chunk right here. That's a distance of 2 pi.
No, pi over 2 to 5 pi over 2.
Oh, I see. I misheard. Pi over 2, not 2 pi. Pi over 2. So you went from here over to 5 pi over 2, and you subtracted those? Good. So that would have been 5 pi over 2 minus pi over 2 equals 4 pi over 2, which is 2 pi. So that would be 2 pi. Good. So that would work. Did anybody go from 0 over to 2 pi? Anybody go that way? A few people. That would work as well. But our period is that. Jathan, what's my frequency? 1 over 2 pi. Good. Okay, midline. Isabel, what's my midline? Y equals 1. Thank you for including the Y. So Y equals 1. That's the middle of my graph. Right. Damien, what's my amplitude for A? 2. It's my distance from my bumps to my midline is a distance of 2. All right. Let's go ahead and look at B. B, period. Aaron, what's the period of my graph B? How did you get by? That is correct. What was that? Did you have a starting place or ending place you looked at? Somebody help us out. How did we figure out that that's pi? What did somebody do? So Dean, you started at 0. We'll go with that one first, then I'll go over to Sophia. So you started at 0, went around, and saw that started repeating at pi. I went too far. At pi, right? So that started repeating there. So that's a distance of pi. Sophia, S, what did you do? All right, so you picked 5 pi over 3. So that's often an easy way of doing it. Pick the 2 top bumps or 2 bottom bumps, all right? And that can help out there. So 5 pi over 3 minus 2 pi over 3 would give us 3 pi over 3, which is pi. That would work. Jacob, what's my frequency? 1 over pi, good. Ellis, what's my midline? Y equals 2, good. So we're at y equals 2 on this one at our midline, middle of my graph. So y equals 2. And then amplitude, Adriana, what's my amplitude? That one is 1.5, the one Damien was trying to give us earlier. 1.5, there we go. All right, any questions on identifying our characteristics of sinusoidal functions? It's a fun word. Let's say that, 5 times fast. Sinusoidal, 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 sinusoidal. All right. So that's identifying from a graph. We can also identify even if we're not given a graph. So for these 2 problems, problem 3, for each problem, the sinusoid has been vertically shifted and has the given maximum and minimum values. Write the equation of the midline for the sinusoid and find the amplitude. So we're going to find both the midline and the amplitude. Now, they're not asking for the period of frequency because we're not given enough information for that, but we do have enough information to find the midline and the amplitude. Now, there's a lot of different ways you could go about doing this. What helps me is to do just a quick sketch. So let's say here's my y-axis, and I have a maximum value of 100 and a minimum value of 20. Note, I didn't put in the x-axis. I don't need that right now. So 120. So 100 is going to be a maximum value. So I'm just going to put a point up there. That's going to be a maximum value. And then I know my sinusoid is going to be coming up to that point and then starting to go back down. And what is it going to go down to? To 20, right? So I have that minimum value down here. And then after hitting 20, what does it then going to do? Go back up to 100. And then once it hits 100, what is it going to do? Go back down to 20, and then back up to 100, and so forth, right? So we have that sinusoidal kind of relationship going on. Now, what we want to find is the midline, and remember the midline splits this in half. So we want to find that midline. And we want to find our amplitude. And remember, the amplitude is the distance between the midline and the max and min. So I want you guys to think about what is some way, with just that information, how could you determine the midline and amplitude? So go ahead and take a minute, think about it, talk in your groups. Can you figure that out? All right, let's go ahead and look at this one. Midline. Sage, what do you have for the midline? And how did you get, and it's not just 60, what is it? There we go. And how did you get 60? Which was that average process that we talked about on the previous page, right? So 100 plus 20 divided by 2. All right. Amplitude. Aiden, what is the amplitude? And how did you determine 40? Good. So if we want to get to 60, then that would be definitely a distance of 40 from both 100 and 20. So you could do one of two things. You could go 100 minus 60, or you can do 60 minus 20. Regardless, that equals 40. It's that distance in between. All right. If you haven't done B, go ahead and do B, please. Take another minute, and then we'll check in with that one. All right, let's go ahead and look at B. Let's see. Ben, what did you get for the midline? Just 112.5? No, it's 0.5. But we're missing something. There we go. Y equals. And how did you find, Ben? How did we find 112.5? So 135 plus 90 divided by 2. All right. Amplitude. Julia, what's our amplitude? And how did you get 22.5? So 135 minus 112.5. Finding that distance in between. Very good. There we go. All right. And so that is our characteristics of our sinusoidal functions.